Alright, let's code. Loki fell off a bit. Did not code every day. But yeah, I just finished this binary search real quick. Took me like a good 3 minutes. I forgot this part again. The L plus. But alright, we did that. That's chilling. Let me turn this down. Alright. Okay. Let's try a sliding window question. Yeah. Cool. Okay. You're given an array of prices where price of I is the price of a given stock on the ith day. You're gonna maximize your profits by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. You know the maximum profit you can achieve from this transaction if you cannot reach the end profit. Buy on day 2, sell on day 5. Okay. The maximum profit. Let me search up what sliding windows. Okay, so in this case, I'm trying to do sliding window. Thing is, the window isn't like a set size, so how would they do that? Let me implement the trivial solution first. O of n squared, which would just be like 2 pointers, and then just find the max, you know. So we have like buy equals prices equal to 0. Buy equals 0, sell equals 1. Oh yeah. How does it give you 5? We should have the outer loop be the cell low-key. Sell, buy. So say I in range, when 1 comma prices. And then here we'll have 0 comma sell. You know? And then we'll do current profit equals prices of buy minus buy. Wait, no. Sell minus buy. Yeah, okay. So this is going to be O of n squared, which is not the optimal runtime. Time limit exceeded. Lucky, is there a way to check if let's see, what can we do here to make it more optimal? So we're checking like here and then here. And then we're checking next here. Then we're checking here. Then we're checking here. Then we're checking here. Oh, this gave us nothing. So then we moved our left pointer over 1. And then we went to 5. Then we went over to 3. Then we went over to 6. I feel like the correct approach should be that we try and find the smallest number that occurs first, and then the largest number. You know what I mean? But that would honestly, yeah, that would be O of n twice, right? I don't know if that will work though, because here the smallest number would be here, and then we have to find the biggest number to the right of that. Let me see if there's anything helpful. What is this? Okay, so I get like the part of the sliding window, but like, isn't the size of the window gonna change? Is this price cheaper than any other price I've seen before? If I subtract current price by the cheapest price I've found, does this yield a greater profit than what I've seen so far? No. So if you start at like 7 and 1, right? Then our profit's gonna be -1. And then we go to 5. 7 minus 5. Is this cheaper than any other price I've seen before? Is 5 cheaper then 1, no. 0 then 1, no. 6 then 1, no. 4 then 1, no. Wait, what? Okay. 4 1 5 2 7. 4 is the cheapest price we start to see. So max profit 0. 1 is the cheapest price we've seen. So now we lose some money, so we can't update max profit. 5 is not cheaper than 1. But if we sell now, we get max profit of 4. I think I kind of get it. So we keep a max profit. And then we keep cheapest equals 0. Cheapest equals price of 0. So let me say for I in prices, if I or actually let me just num in prices, if num is less than cheapest, then we can update cheapest equals prices of num, you know, and then we could say if else if prices of 0 minus cheapest, or not price of 0. If num, I don't need prices num here either, so num minus cheapest is greater than max profit, then we update max profit too. So max profit equals num minus cheapest. Then we can just return okay. So I kind of understand it, but I don't really understand like the concept of sliding window completely. Also, this didn't seem like a sliding window problem because they're moving like this. Here we're keeping two separate like variables that we're keeping track of, and they're just looping through the array. Yeah, let's watch the video for this.
Hey everyone, welcome back, and let's write some more neat code today. And don't forget to hit the like button, it supports the channel a lot. So today let's look at LeetCode 121, best time to buy and sell a stock. So if you know a little about the stock market, the saying is usually buy low and sell high. So in this case, we're given an input array. Now each value represents the price of a stock at a particular day. And we are given one transaction, meaning we can buy on one of these days and then sell on another day. And we want a transaction that maximizes our profit, and then we want to return that profit. In this case, if we buy on day 2 when the price is 1 and sell on day 5 when the price is 6, that's what's going to maximize the profit for us. So as always, I'm going to draw a picture and show you that this problem is actually not too bad, even the optimal solution. So on day 1, it was at price 7, and then it went down all the way to price 1. The next day, it went from price 1 all the way up to price 5. And we could just keep going with this, right? So next day it went down, and the next day it went up. And the last day, it went down again. So looking at the picture, it's pretty clear that the max profit we can get is simply by taking the minimum here and the max here. And if we look at the actual values for that, we see that this is 1, this is 6. So the profit is going to be 6 minus 1, which is 5. But notice how there's actually a greater maximum than this one, right? Like this is 6, but this is 7. So why can't we just do this? Because then we get 7 minus 1, which is 6, which is even bigger than 5. Well, it turns out we know that time moves in one direction, right? We can't go back in time to sell at this price. So how are we going to solve that problem? Well, there's a pretty common programming technique, 2 pointers. So we're going to initialize a left pointer on day 1 and our right pointer on day 2, which makes sense. Right is going to be to the right of left. And so we're going to see what's the current profit right now from here to here. Well, it's going down, right? That's not good. It's negative. And in this case, left is...
Okay, so I don't think I did a 2-pointer solution, but I think I see where the 2-pointer solution can go to. So if I did the 2-point solution, we did L equals 0, R equals, or yeah, let's name these better. So we'll say buy equals 0, sell equals prices of 1. No, price sell equals 1. Yeah, okay. And then we say if, then we can also keep minimum cheapest equals okay, so with these we could go like this. So say while sell is not greater, while sell is less than length of prices, right? I should use length of prices minus 1. And then we could do and then we say if the current profit is greater than the max profit, then max profit equals cheapest. No, max profit equals current profit. You can also do if yeah, then we gotta do some kind of updates to these. So we say if we'll say if sell or prices sell is less than cheapest, then cheapest equals sell. No, prices of sell. Right? Let me see. Okay, so in this example, he has 2 pointers here. R is the cheapest. So this is a negative profit right now. If we update L or update R, and then also this will be cheapest. If we update R and L, we'll get. Oh, okay. So we should update L to the cheapest. Where is it? Yeah. Then we say we buy at the cheapest too. Did this work? Hello? Buy, sell. Sells 1, buys 0. If we do 2 minus 1, 1 is greater than 0. Oh, does it ever go in here? Sell is less than the price is minus 1, 2 less than or equal to. Fuck. Okay, so 3, 2. This is not bigger, but 2 is the cheapest we've seen. So then it goes 2, 6 at the next window. And this gives us 4 is the current profit. So that is bigger. 6 is not the cheapest we've seen, so we don't update. We just move sell up 1, so 2, 5. Is equal to 3. 5 minus 2 is 3. 3. Three is not greater than 4, so why did it update? Did it update properly here? Okay, so we start here. If prices of sales are 2. So we said buy. This would be the cheapest. Oh. Yeah, I was giving it the actual value instead of the index. Okay. Yeah, so this looks like more of a sliding window solution than the one I was using before. Also, I feel like I don't need cheapest here. Right? If I got rid of cheapest, and instead I did this, should still work, right? Yeah. Cool. How did I use more memory? I don't know. That's weird. Oh, okay. So it's just like tweaking.
It's going to be when we can buy right. Right is less than left. Why would I pay 7 when I could wait 1 day and pay 1? So that's basically how the algorithm works. Since our right value is less than left, we're going to update our pointer left. So left is now going to be on day 2 and right is going to be on day 3. So now we see that the right value is actually greater than the left value. But what's the profit? The profit in this case is going to be 5 minus 1, which we know equals 4, which is so far our current update, our right pointer. Now let's compare our left and right. So we're buying here, we're selling here. In that case, the profit is going to be 3 minus 1, which is only 2. So if you take a look at our current max, it's 4, so we're not going to update our max profit. And we notice that our left pointer, we're buying low and we're still selling high. It's not as high as this, but we still don't need to update the left pointer. And so now we get to the actual result case that we already know about, but let's compute it. So this is
like
at
more
6.
of a 2-pointer problem than sliding
This
window.
is at 1. So we found a new max profit. 6 minus 1 is 5. So let's update our max. So our algorithm is going to keep going even though we can tell by the picture that we did find the max. So it's going to end up checking this last case, which left we're buying 1 and we're selling at, I think this is 4. So we know 4 minus 1, we have 2 pointers. Okay, now array, so extra memory. Left is going to be Left is going to be initialized to 0 and right is going to be initialized to 1, just like in our picture. We know left is buying, right is selling. We can initialize our max profit to 0 as like the default case, and we're going to keep iterating through prices while our right pointer has not passed the end of prices. Now we want to check, is this a profitable transaction? And how do we check that? Well, if prices of left is less than prices of right. Now, if this is profitable, let's calculate that profit, which is going to be so this is just the math, right? Prices of right minus left. And now we can potentially update our max profit, but we don't know for sure. So we're going to check the maximum of the current max profit as well as the profit that we just computed. So whatever the max is going to be assigned to the new max profit. But it might not be a profitable transaction, which in that case, we can update our left pointer. Now, regardless of the conditions, we want to update our right pointer. And so this is obviously going to keep going until our right pointer is out of bounds, in which case we've gone through all of the values and we know that max P has the result that we want to return. So I actually had a small bug over here. Instead of incrementing left by 1, if the left price is not less than the right price, we don't just want to shift our left pointer by 1, we want to shift it all the way to the right because we found a really low price. We found the lowest price that we could pretty much. We basically want our left pointer to be at the minimum. And you are right high pointer solution.
Alright, I'm done.